Hi, I'm Anamita Somasundram and this is my emath YouTube assignment. So let me start by explaining these two graphs that I drew. They both show the same smooth curve, which stands for the actual solution to some differential equation. And in this case, I used y equals to x squared, which when differentiated gives 2x. We usually don't know this exact curve, and that's why we use methods like Euler's to approximate it. In the first graph, I drew just one tangent line at the point x equals to 1, and this shows the slope of the curve right there. If you were to only follow this single tangent line forever, we'd end up way off the real curve. So this helps us to see why we can't just rely on one slope, and that's because the curve keeps changing. In the second graph, I showed the same curve again, but this time I used Euler's method with a big step size of h equals to 1. And that means we start at x equals to 0, take the slope there, and then use it to jump directly all the way to x equals to 1 in one big straight line. So we can see that this straight jump misses the curve by quite a lot, and it's a good way to show why taking smaller steps is important in Euler's method. It lets us keep adjusting the direction and stay close to the actual curve. So for example, if we used zero point 0.5 or zero point 0.1, then the tangent lines would be much closer to the actual curve. Now let me show how I did this properly using smaller steps in my Excel sheet. This is the differential equation we were given. So in Excel, I set up three main columns. X, which increases by small steps of zero point 0.1, y, which is our approximate solution at each x, and fxy, which is the slope calculated at each point from our differential equation. Then for each row, I used Euler's formula, which is this. So we start at x equals to 0 with y equals to 1, and then move to x equals to zero point 0.1, and then find a new y based on the slope. And then we keep repeating the same thing all the way up to x equals to 1. When we reach x equals to 1, the Excel sheet gives us 1.911, which is our Euler estimate using small steps. So finally, let's see how close this is by solving the equation exactly. We start by separating the variables and then integrating both sides, which gives us this. So we use the initial condition of when x equals to 0, y equals to 1 to find c, and then c equals to half. So the solution is this, and then we plug in x equals to 1, which gives us y equals to 1.915. So the exact value at x equals to 1 is about 1.915, and our Excel sheet with Euler's method gave us 1.911. That means our approximation is actually super close with an error of only around 0.004. So that's how Euler's method works. It builds the solution step by step using small tangent-like lines. We saw how large steps can miss badly and how smaller steps in Excel give us a close estimate and how it all compares to the exact solution. I hope that was easy to understand. Thank you for watching and have a great day. Please like and subscribe.